Let's discuss two problems because they are very simple and they are pretty much similar. Leetcode problem number 104, which asks you to find the max depth, and then Leetcode 101, which checks if the trees are symmetric or not. Before we discuss, please share, like, subscribe, and hit the bell button for notifications. Also, I have had a lot of questions to the community page. Please check it out. Now back to the first problem, maximum depth of a binary tree. So it uses the recursion pattern. So if you're given a tree like this, you need to calculate the depth. So max depth is basically, this is depth level 1, this is depth level 2, and then this is depth level 3. So recursion is the easy way to go. So you calculate the left depth and then the right depth, and then you say whichever one is greater, add 1 to it and send it out. So the left branch may not exist, so then also the depth, even in this case, if this segment is not there, 4 and 5 nodes are not there, it is still max depth of 3. So that's why you need to take this STD max. So in this case it is 3. The answer is the max depth is equals to 3. So that's it for problem number 104. Moving back to 101, like you are checking whether this tree is a symmetric tree. Basically, if you draw a mirror, if you place a mirror in between, so this tree looks exactly same like the mirror opposite. Not exactly same because it is 3 4 here and it is 4 3 here. So they are not equal, but they are symmetric. I call this as left right equals right left pattern because you will see in the implementation that is the key to this solution. So you start off with the helper function called eSymmetric, but you call it with root and root, 2 parameters, which is, this one is the recursive function, so which takes in 2 parameters, tree left and right. If both nodes are null, it is symmetric, and if they are not null, then you have to make sure left equals to right, otherwise they are not symmetric. Otherwise you do left dot val equals to right dot val, and if that is not true, then it is not symmetric. And then if this condition is satisfied, and you have to check whether left dot left equals to right dot right. So in this case, if you are checking these two, right, you need to make sure that 3 5 6 tree in this case, right, you see 3 5 6 is equals is basically symmetric with 3 6 5. So if you see for 2, left dot left is 3 5 6 tree, and this one is 3 6 5 right dot right, basically for this 2. So that's what you are checking here. Left dot left should equals right dot right, and then this is where the actual pattern name comes. Left dot right should also equals to right dot left. So in this case 4 7 8 should be symmetric with 4 8 7. So 4 8 7. So in this case it is a symmetric tree. This example is a symmetric tree, and that's it. Let me know if you have any comments. Otherwise, I will see you in the next video.